So I am now live streaming this webinar on YouTube. I will post the link, the YouTube link on Twitter, and then we'll be ready to go. All right. Good evening, good afternoon, good morning, depending on where you are in the world, to anyone who can make it live and everyone who will be listening to the recording. So what I'm here to do this evening for me is to take a look back over the 20 years or so that I've been working as a developer on accessibility technology for blind people, and also do a little looking forward at what's to come, both in the work that I'm involved with and the industry in general. So the goal is not to focus exclusively on what I've done, although I will be talking a fair amount about what I've done, because of course that's the work that the part. I mean, what I've done is the work that I'm most familiar with, but I'll also talk about what was going on in the surrounding industry and the underlying technical problems. So to set the context for where we were at 20 years or so ago, end of 2001, beginning of 2002, Windows XP had just come out. If anyone remembers that, Windows XP had just come out. A lot of us, myself included, were still, though, running Windows Millennium or Windows 98 second edition. The leading screen reader for Windows was JAWS. And at that time, a license for JAWS cost, and I'm not making this up, around $1,195. Other options such as Window Eyes were less expensive, but still several $100s. And of course, if you bought a one-time license and that was it, you were going to get out of date. You had to pay for a software maintenance agreement, or SMA, to keep your screen reader up to date. And a JAWS SMA, I'm told, cost around $160 a year. And you had to keep your SMA current. If you let it lapse and then you wanted to update, you would have to pay perhaps for a few years of SMAs. Hang on, my phone just went off. Okay, my phone will not be going off again. Sorry about that. As I was saying, if you let your software, your JAWS SMA lapse, and then a few years later you wanted to update, you would have to pay for a few years worth of SMAs. Now, the Windows XP and Windows 2000 before it had built in a very basic free screen reader called Narrator, but Narrator was really just barely enough to do some very simple things in the operating system itself and get your real screen reader installed. And as I said, a lot of us were still running Windows Millennium or 98, and that did not have any sort of screen reader built in. So one last thing to kind of set the context and just give a flavor for what was going on at the time, what things sounded like at the time, and also a bit of what one might call blind culture. My first audio clip that I'm going to play is a famous satirical production by the then then teenager Patrick Purdue, who was and is a genius at audio production. Most famous for singing Deck Talk, but has also done a lot of other clever things. And this piece is called JAWS Patch, and it's making fun of an update that came out for JAWS in the mid-2000 that had the unfortunate side effect on some people's machines of wiping away the user's JAWS settings and scripts and such. And this clip begins with the music and sound effects and voiceover, human voiceover at first, of the original JAWS installer, and then proceeds to make fun of it. So I'm going to play that now.
Welcome to the JAWS for Windows Patch Setup program.
Please relax while Dr. JAWS examines your system. This may take a couple of minutes.
Dr. JAWS, please wait. Dr. JAWS is diagnosing your system. Dr. JAWS has found settings for JFW which you have spent years and years customizing for each of your applications. Dr. JAWS has no respect for you nor your settings files. Dr. JAWS is now permanently deleting all of your JFW settings files. Please wait. Dr. JAWS found errors with JFW. Too bad. Dr. JAWS will not fix them. Dr. JAWS, this program has performed an illegal operation and will be shut down. If the problem persists, contact the program vendor. Close button.
Thank you for installing the JFW update patch. Now you're screwed. You are a loser. Ha 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 ha.
So that was the JAWS patch audio clip, and the main speech synthesizer that you heard in that clip was an earlier version of the ETI Eloquence speech synthesizer, which a lot of us still use. There, hang on. I think I need to check, but I think maybe I'm getting chat messages. Oh, never mind. I was I was seeing text appear on my screen, and that was just the closed captioning. Anyway, so a lot of us still use the ETI Eloquence speech synthesizer. The final version of that synthesizer that a lot of us still use is a somewhat newer version than the one in that audio clip, but it's approximately the same thing. Now, so where did I come into the picture? Well, around the time that that audio clip came out in 2000, so a bit more than 20 years ago, I've and thank you, Richard, for pointing out that the human voice at the near the beginning of the clip was Earl Harrison, who was, at least at the time, a well-known trainer. Did Zoom not hear the audio clip? Okay. If Zoom didn't hear the audio clip, then I'm gonna have to play it again. Okay, that's interesting. Richard says he heard it just fine. Well, then I will continue to play audio clips using that same method. I'm sorry if some people aren't able to hear it. Andrew, you who sent, and Andrew's chat message only went to me, but if any of you were not able to hear the clip, then you might need to update your Zoom app, because I'm using a fairly recent feature of Zoom to play the file directly. So moving along then. So like I was saying, so where did I come into the picture? At around the time that JAWS patch clip came out, I was working on trying to make Linux easier to use for blind people. And I had put together a mini Linux distribution with package with SpeakUp bundled, designed specifically to be easy to use for DOS and Windows users, because it could be unzipped directly onto your DOS partition. Remember, most of us were running Windows 98 and a bit later Millennium, which could boot into DOS mode. And that mini distribution was called ZipSpeak because it had the SpeakUp screen reader included. Thank you, Richard. Yes, I did some tutorials for ACB Radio main menu as well. But ZipSpeak had the SpeakUp screen reader for Linux bundled, and it was based on the ZipSlack variant of the Slackware distribution. And then the other project that I was doing at that time was a command line interface to the Real Player engine called TR Player. Then, beginning of 2001, so still a bit more than 20 years ago, but but it's important. Beginning of 2001, Mike Calvo, who soon became my boss and is now my business partner and best friend, Mike posted on the mailing list for the SpeakUp screen reader asking for help getting a Linux box up and running with SpeakUp, and I was the one who offered to help. So that was my that was how I ended up becoming his system administrator and soon his lead programmer. And Mike was working on a new product for blind people called Freedom Box. And the slogan being "Now freedom comes in a box." And the goal of this product was to make computers, and particularly the internet, more accessible, more usable, and more affordable to blind people who were just looking to get online at home, not to use it for a job or for education. The comparison that we used at the time was that Freedom Box was like an AOL, or America Online, for the blind. And the first version of Freedom Box was using not only speech synthesis and audio output, but speech recognition. So you could either speak your choices, or you could press numbers on a keypad. If any of you remember, back then we had phone, like telephone network, actual telephone based voice portals like Tell Me, where you could dial up a toll-free phone number and get a menu-driven interface that you could either talk to or press your choices on the keypad and get weather and sports and stock quotes and movie listings and whatever else. Freedom Box was a very similar interface to Tell Me, and in fact used a lot of the same underlying technology. Particularly at that time, there was a hot markup language for voice applications called Voice XML, and we used Voice XML. We combined it with some other components, such as an audio player for being able to stream internet radio stations, and Freedom Box was on a desktop computer, not on a phone, but it was a very similar interface. And so unfortunately, the audio demos that we had of Freedom Box have been lost. I'm sure some pack rat somewhere has those files, but I don't. Mike doesn't. We don't have them. What I do have is an audio clip that haunted us for a while, and this was a brief spoken word portion from one of the very first demos of Freedom Box that was played on ACB Radio Main Menu, which was a weekly audio program about technology from a blindness perspective. And the creator and original host of Main Menu, Jonathan Mosen, introduced this demo with a little overview of what Freedom Box is, and he made a statement about what he thought the future of Freedom Box could be that haunted us for a while. And the background music that you're going to hear behind this clip is because the only copy of this clip that I could find was in a documentary about the company behind Freedom Box, Ceratec, that Mike produced later on. So check this out.
It's my view that this product is going to do one of two things. It's either going to revolutionize in a way that perhaps has never been seen before access to the internet for those who are not financial enough or perhaps techy enough to be computer users, or it's going to flop quite severely.
And that echo effect was added as part of the documentary as well. So the company didn't flop quite severely, but the original Freedom Box product didn't really take off either. We had some limited and we had some modest sales when Freedom Box actually came out in 2002, and we released we released the so at we had a service called the Freedom Box Network that you paid a monthly subscription fee for. It started out at $9.95 a month, and and so we had that, and then you could either download the software and run it on your PC, and the full download with the AT&T Natural Voices speech synthesizer in it was about 600 megs, which of course to download that on dial-up was a pain. You could also request that it be mailed to you on CD. Excuse me. Getting over a cold. Or you could buy what we called the Freedom Box standalone, which was basically a small form factor PC running Windows XP, and with the Freedom Box software pre-installed on it and set to come up when the PC started up. So we had, like I said, it was a menu-driven interface, a large directory of internet radio stations. We had some audio content that you could listen to, such as old time radio and dramatic audio of various kinds, as well as the audio tracks of movies and TV shows with audio description. And for any sighted people listening to the recording who aren't familiar, audio description is basically where someone is narrating what's happening on screen in the movie or TV show, and those narrations are generally inserted between lines of dialogue. And then we had email, where you could have your email read out loud, and you could either record voice messages, or if you were proficient with using a QWERTY keyboard, then you could type your messages as text, although the interface for editing text-based messages was very simplistic. And then later we had forums and chat rooms, and we also had simple document scanning. Using a flatbed scanner, you could scan a page at a time and have it read out loud. And that was about the extent of what, a couple of other things. We did have a web browser. We had a process that could convert web pages into voice XML and read them out loud, and then let you speak the name of a link that you wanted to activate. It worked for simple web pages. It was by no means a full-featured web browser. And we also had what we called the shopping mall, where we implemented our own voice-based interface to Amazon.com. And that interface was based on a programming technique called screen scraping, where we would pull down the HTML of a page from Amazon and basically look for known patterns in the HTML and use that to pull out the information and available options. And this technique was prone to break, and it broke often. And on more than one occasion, I would find out that it had broken, and I'd have to scramble to go back in and fix it. So that was Freedom Box version 1, and we got some sales, and it was useful for some people, and the people who did take a chance on it, from what I recall, generally appreciated it. But it was never taken seriously by the establishment, I guess, of access technology trainers and basically people who who were influential in determining what access technology products got bought for people. And so we knew we needed to do something different for version 2. But before we got started on version 2, there was another thing we did that I think was kind of a first for the industry. And that was that we made FreedomBox, the FreedomBox software, available on a USB flash drive. Now, these drives went by various names at the time. This is like early 2003 at this point. And one of the names that these drives went under were USB keys. And in fact, one of the early products in this category was called the CyberKey. And Mike found out about this in the beginning of 2003, and he asked me if I could make FreedomBox run on this thing, and I could. And I realize I've now spent almost half an hour on the first couple of years, but so we got FreedomBox running on this USB flash drive, so you could walk up to a computer in a public place, or a friend's computer, or computer at a relative's house or whatever, and plug in this USB flash drive and run the software. So for FreedomBox version 2, what we ended up doing was we did speech recognition held on as an option for a little while in version 2, but we ended up dropping it. Yes, the actual product that we sold was called Key to Freedom, and the original one was a 128 megabyte flash drive. But anyway, back to FreedomBox version 2. We ended up developing a self-voicing web browser based on the Mozilla engine. And by self-voicing, I mean that it had text-to-speech output built into it, so you didn't need a separate screen reader. And within the limitations of what I was able to do at the time with my still developing programming skills and the cross-platform Mozilla code base, we made the keyboard-based interface to this browser fairly similar to JAWS, with one notable exception. A couple of notable exceptions, one temporary and one that would last. The temporary exception was that with JAWS and other screen readers, it's common for the screen reader to use fairly unusual modifier keys, such as caps lock or insert. So you would hold down, for instance, you would press caps lock up arrow or insert up arrow to read the current line. Whereas with FreedomBox version 2, it was just control up arrow or control down arrow. That limitation went away with the system access screen reader, which I'll get to shortly. The more permanent difference was that JAWS and other Windows screen readers had and still have a distinct forms mode that you would have to go in and out of when filling out a form on a web page. And Mike and I thought we could do better. And so what FreedomBox version 2 did, and what the system access screen reader does even now, is if an edit box on a form received the keyboard focus, then the keyboard commands for navigating a web page would become inactive, except for up or down arrow for moving out of the edit box, and you could just type in the edit box. For other types of form controls, the full set of keyboard commands would remain available. Excuse me. So we did some other user interface things to make web browsing more convenient. For instance, one of the common challenges of browsing a complex mainstream website then and to some extent now is that your screen reader would start reading at the top of the page, and it would be a challenge to find your way past all of the navigation links and other clutter to the main content of the page. And we had a heuristic for trying to find the start of the main content on the page, and we would jump straight there. And it wasn't foolproof, but it worked and works a lot of the time. Of course, now there are also what are known as landmarks as part of the ARIA, Accessible Rich Internet Applications Standard. And it's easy to just, for web pages that have these landmarks, it's easy to just look for the main landmark and start there. But at the time that we were working on this, that was still at least a few years away. Another thing that we did that made it easier to browse the web was we had a community database of labels for graphics and other things on websites, which we called Community Supported Accessible Web, or CSAW. And one of the dramatic early successes for that database and for our process for trying to automatically browse a web page and find labels for images was Amazon.com again. Because at this time, like 2003 to 2004, Amazon.com was infamous for not having alternate text or alt text on a lot of its links. And when you read these navigation links with JAWS or the like, JAWS would, in the absence of alt text, JAWS would try to read like the end of the URL. And these were highly inscrutable, dynamically generated URLs that didn't tell you anything useful. But with our Seesaw database, Amazon.com was a lot more usable. And Mike dramatized this difference in around 2004 or so in an audio commercial that he produced for FreedomBox version 2. And I don't know if he actually got this commercial played anywhere, but I'm going to play the opening 25 seconds or so of it.
Tired of fighting with your screen reader?
And not find graphic. Land.
Are you tired of losing it when you visit a web page? Are you tired of inaccessibility on the World Wide Web? This is your average screen reader.
250 links. Amazon.com. Vertical bar. Link ref equals top nav SD gateway 102-7,411,059-5,566,966.
This is FreedomBox.
Amazon.com with pages selection. Books, music, DVD, VHS.
Then you know what? You need FreedomBox.
And that little snippet of browsing Amazon with FreedomBox version 2 also demonstrated another little feature that I'm particularly fond of that I think was my idea, and that was the use of beeps to indicate the links. I love using that feature when I'm reading a Wikipedia article, because Wikipedia articles tend to be dense with links within the text, and I think the text flows better when you don't have it interrupted with the word link here and there. So I'm going to play one other audio. Well, actually a series of audio clips associated with FreedomBox version 2 before I start talking about actually developing a Windows screen reader. And if anyone here or listening to the recording actually used FreedomBox 2.0 when it came out, then you might remember the very over-the-top audio that we had in our talking installer. And with Mike's blessing, I'm going to play these clips in sequence so you can get the full experience. So Mike, before he got into running software projects and running a software company, he was and still is an audio producer, and so he really went to town with these audio clips and with background music and effects and whatnot. And I will warn you, if you're listening to this on your speakers at work, you might want to change that at this point. And the female voice that you're going to hear in these clips was a lady named Kim, who recorded the pre-recorded voice prompts from FreedomBox version 1, which was the very simplistic voice recognition based menu based version. So here is what you heard when you ran the installer for FreedomBox version 2.
Welcome to FreedomBox version 2.0, featuring the power of Fluid Flexible User Interface Desktop.
This program will install all the necessary software for you to access the FreedomBox network.
So there is the first screen. By the way, to any sighted people who are in here, apologies that my screen shares here are just blank, but Zoom doesn't have an option to just play an audio file. So next you would hear this.
You must accept the license agreement to install the FreedomBox software. To accept it, press Enter. To cancel the installation, press Escape. FreedomBox End User License Agreement and Privacy Policy. License Agreement. Please read.
I do not need to keep playing that. Yes, Kim proceeded to read the whole EULA. And that audio clip, of course, doesn't have the over-the-top production of the others, but it is nevertheless over the top in its own way, in that we had a human voice talent read the whole EULA. So after you moved on past that, you would hear this.
Now you may change the directory where the FreedomBox software is installed, but you usually don't need to change it. To accept the default, press Enter. To cancel the installation, press Escape.
And I don't even know why we had that screen in there. I think we just kind of took it for granted that setting the installation directory was part of a Windows installation wizard. It wouldn't be long until more forward-thinking software installers for packages like Skype and Google Chrome would just get rid of that step. Then for the actual installation itself, you would hear this.
Please wait while I install the software. This may take a while.
And if your PC was still chugging through the installation after that clip ended, then it would chug in silence. And then And then after that was done, you would hear this.
FreedomBox setup is complete. It is strongly recommended that you restart your computer before running the FreedomBox software for the first time. Do you want to restart your computer now? Press Enter if you do, or press Tab and then press Enter if you don't.
So that was it for the installer. By the way, I don't think we actually needed the reboot step. Richard is correct. And I almost forgot to mention that FreedomBox version 2 was ported to Linux. Mike indulged me on that and let me port it to Linux, even though that meant that I had to solve some extra problems that I didn't have to do in the Windows version, such as writing my own program for mixing multiple audio streams, which had been a solved problem in Windows since Windows Millennium, or possibly, or depending on your driver, possibly even 98 second edition. Yes, Richard, I know you first fell in love with FreedomBox on Linux. Unfortunately, the Linux version generally didn't sell well, and the reception that we got from the existing blind Linux community was pretty negative. So, and then of course, once we really got going with System Access, the Windows screen reader, we killed off the Linux version a couple of years later. There was one other thing that we did. Yes, thank you, Richard. The Linux, a lot of blind Linux users were not nice at all to us. But one other thing that we experimented with in Linux was we got FreedomBox version 2 barely running, slow as molasses, really, on a Linux-based personal digital assistant, or PDA, called the Sharp Zorus. And this, yes, the sound mixing program that I wrote for Linux was called USound. For the U stood for useful, which was my not so subtle jab at the other Linux sound mixing options. But I ported FreedomBox version 2 to this Linux-based PDA called the Zorus, and it ran very slowly because I was running Mozilla and Python and other fairly heavyweight stuff on this little 400 megahertz Linux ARM-based PDA with 32 megabytes of RAM or something pitiful like that. But it was barely enough for Mike to take it in and demo it to some people, because we thought that to get investors, it would help if we could demonstrate FreedomBox running on a portable device, and that didn't really go anywhere. But it was still an interesting project. So FreedomBox was running on Linux as well, and in addition to being a web browser, it was also, again, an audio player for listening to internet radio stations and the various audio content that we had on the network. We also had a feature called Media Library, where you could listen to your own MP3s. And one of the things we had that I think was a bit ahead of its time for 2004 was a feature called the Home Server, where you could run this Windows service or Tray applet. We had both versions on your desktop PC at home and leave it running, because of course it was common for people to just leave their desktop PCs on all the time back then. And then if you were running FreedomBox on a laptop or on a public computer using the USB flash drive, then you could connect back to your home computer and stream audio from your media library, or download files from your home PC. And I remember at the 2004 summer convention of the American Council of the Blind, we demoed that feature a lot and also used it in our hotel room to listen to music from either my home computer or Mike's, when we were hanging out in our hotel room. So that was FreedomBox version 2. Another thing we had as part of that self-contained talking environment, and this was a feature that really got us to start thinking about possibly embarking on developing our own screen reader, was that you could access third-party voice chat services that were available at the time. And we had built-in support for one voice chat client in particular. I forget what the client was called, but there was a website called forthepeople.com. Speak Freely was the voice chat client that we had built in to FreedomBox for our own voice chat service. But the third party client I'm thinking of, it was the one that was used by forthepeople.com back in 2004. I think it was called Chatterbox, maybe. But at any rate, this third party chat client had its own user interface, and we were never able to reach a deal with the developer of that client to develop our own talking interface for it. So we couldn't really make that app talk within FreedomBox. And so that plus just other things that were outside the scope of our little self-contained world got us to start thinking about possibly developing something resembling a Windows screen reader. And the screen reader at this time was conceived as an add-on for FreedomBox. So we unimaginatively called it FreedomBox System Access, or FBSA for short. And when the FreedomBox name ended up being dropped a few years later, the screen reader became simply System Access, which is maybe not the the best product name, but that's what it was. And so I started prototyping this screen reader in about October of 2004, and I started. So I need to mention at this point that I am hugely indebted. Yes, Richard, that's right. That's what it does. It makes the system accessible. But anyway, I am hugely indebted to a research group at the University of North Carolina, Chapel Hill, in the computer science department, who made some open source libraries available for the Python programming language for accessing Windows features that were useful to access technology developers. There were 3 of these libraries in particular that I used. PYAA was a library for using the Microsoft Active Accessibility, MSAA, accessibility API. And shortly, I'll get into more about what accessibility APIs were and are, what their limitations were at the time, what we had to do instead a lot of the time, that sort of thing. So there was PyAA for using Microsoft Active Accessibility. There was PyHook for hooking into the keyboard input process so we could intercept keystrokes. And this one wasn't as important to us because we already had our own way of doing text-to-speech, but PyTTS gave us access to the Microsoft Speech API. And we did make use of that as well, although we also had the DeckTalk. We had a license to the DeckTalk speech synthesis software. I could go into a whole tale about trying to get a good version of DeckTalk for Linux, but I need to keep moving along. And so this research group at UNC had developed these libraries for their own projects, and they put them out as open source. And yeah, maybe this does need to be a series. But I'm gonna try to pick up the pace a little bit here. But these libraries were a huge help in starting off my process of prototyping a screen reader. And System Access outgrew these libraries entirely within a year or so, but they are what gave me my start. And so I started prototyping System Access in 2004, and it took me all of about 3 days to realize that to realize what the whole rest of the industry already knew, which was that Microsoft Active Accessibility was not going to be nearly enough. In fact, MSAA was not even enough to give us access to Notepad, the simplistic text editor in Windows. And what I finally discovered was that for Notepad, I had to use a Win32. So the Windows, the core Windows application programming interface, or API, is called Win32. And I realized that I needed to use a Win32 API feature called Window Messages to pull information out of the standard edit control. And so within a week or so, I had a very preliminary prototype of System Access. And at this point, it was about on par with Narrator in terms of functionality, although with what I like to think is a more polished user interface. Unfortunately, I did not prepare any audio clips of Windows XP era Narrator. It wasn't pretty. The Microsoft Sam voice was awful. But so we had a better user interface and access to better text-to-speech voices thanks to DeckTalk. Over the next month or so, I continued to build out the functionality in System Access. In particular, I made it work more or less with Microsoft Word, and then around the 1 month mark in late November, I discovered 2 other problems in quick succession, which were at this time sort of core problems with Windows screen reader development. The first problem I discovered when I was trying to make System Access work with Internet Explorer. And this was the absolutely abysmally slow speed, the inefficiency of running in what we in the industry call an out of process context. And what I mean by this is System Access was, so the way that any modern operating system works, each program, and I know that any programmers in the audience are listening to the recording, I'll get this, but I have a mixed audience here, so bear with me. But on any modern operating system, each program runs in its own isolated and protected area of memory, its own process. And when 2 programs running in different processes want to interact with each other, they have to go through the operating system to basically copy messages back and forth between the 2 areas of memory and switch the CPU back and forth between the different tasks. And this procedure of what's called inter-process communication, or IPC, going back and forth between processes, has overhead associated with it. And if you take an API, or application programming interface, that is based on making several small fine-grained function calls to get some information, and you translate those function calls into what we call cross-process calls, again, inter-process communication, then you've just slowed down that interface by orders of magnitude. And when using either MSAA, Microsoft Active Accessibility, or the Internet Explorer Document Object Model, DOM, or for that matter, the Microsoft Office object models that we all used at that time in a cross-process way, you had exactly that problem. And so when I took the code that I had written for FreedomBox version 2, where our self-voicing talking component was running as part of the Mozilla process, and I translated that code to use the Internet Explorer DOM in a cross-process way, having the system access process call into the Internet Explorer process, it was slow. And we're talking several seconds to load, to process a not very complicated web page. Excuse me. So that was the first problem. The second problem I ran into was that while Microsoft Active Accessibility plus Win32 window messages plus Internet Explorer DOM and Microsoft Office object models could give us access to a lot, they couldn't give us access to everything. And even parts of Microsoft Word, not to mention other applications like Real Player, Skype, things that we all used back then, didn't make all 100% of their user interfaces accessible in any of these relatively approachable ways. I was going to have to do some variant of what every Windows screen reader developer before me had done, which was to develop what's called an off-screen model, or OSM. And the way an off-screen model works, worked back then and works now to the extent that it's still used, which is fading fast, is that in using a couple, one of a few different techniques, and I think there's, as of Windows 11, there's really going to be one technique left standing, and I'll get to that. But the screen reader intercepts calls to various graphics related functions in the Windows API, and using the information that it can grab from the application through these intercepted calls, the screen reader can reconstruct a model of what is on the screen at any given moment. And so that model would have information like, at such and such coordinates, there's a string of text. At coordinates 1, 2, 3, there's a graphic with a given checksum. The background color of this piece of text is whatever. Here are the pixel offsets of all the characters, and so on. And with that information, the screen reader can not only read what's on the screen, but use heuristics such as the text with a particular background color is for the selected item, and use those heuristics to figure out what to read automatically, because just reading the whole screen at once would not be very useful. So I mentioned that there are a couple of possible ways of doing an off-screen model. And in 2004, all of the other commercial screen readers for Windows were using something called the driver chaining manager, or DCM. And this was an industry standard that these screen reader developers put together and that Microsoft ratified for allowing the screen reader to install its own display driver in front of the real display driver. And if multiple screen readers were installed on your PC, then these multiple fake display drivers would be chained one after the other. And these were kernel level drivers that would be installed, and that when activated would start intercepting these function calls at the kernel level and reporting information back to the screen reader. And so that was what all the other screen readers were doing. And of course, these being kernel drivers, meaning in the core of the operating system, you had to have administrator rights on the PC where you were going to install this driver. And so Richard points out that remote access applications such as LapLink or PC Anywhere also added to the chain. I knew that these remote applications used mirror drivers, which was the sort of variant of this approach that screen readers had to start using in Windows Vista. So you had to have administrator privileges on the PC where you wanted to install these drivers. So you weren't going to just walk up to a public PC, pop in a USB drive and run JAWS. JAWS and WindowEyes, the other commercial Windows screen reader in the US, were made available on USB thumb drives, but you had to install this driver separately. What we did was, quite by accident, I sort of rediscovered a different technique that had been used by some screen readers in the Windows 9X family of operating systems, but none of them had really latched onto it in the NT family of systems, such as Windows 2000 or Windows XP. And this technique is colloquially known as API hooking. And basically what it amounts to is injecting a DLL into an application process, not at the kernel level, but what we programmers call user space, and intercepting the function calls at that level. And I never actually wrote the code that did the low level machine language tricks to do the actual process of intercepting the function call. There was an off-the-shelf library that a commercial product at the time that I used to do that. And now there's an open source package that can do the same thing, and that's what NVDA is using. NVDA being the open source Windows screen reader that got going in around 2006. So API hooking allowed a screen reader to inject itself into any process that the OS would allow it to access. And if you had administrator rights, then that would be any process running on the system. If you didn't have administrator rights, then that would be any process that was running under the same user account that you were running on. And that was good enough. And while the actual low-level process of intercepting the function calls was taken care of, the higher level problem of building an off-screen model around those function calls was still a difficult art. And when I had a friend at the time who had been in the industry for a little while and had connections, and when I told him that I was working on a Windows screen reader, he basically told me, "You have no idea what you're getting into. It can," I forget the number he gave me, but it was something like 1 or 2 person years of development effort to develop an off-screen model. And looking back, I believe it. but I spent while working on System Access version 2.0 in 2005 to 2006. I think I dedicated at least a few solid months to getting our off-screen model as good as it was going to be. But nevertheless, with System Access 1.0 in late 2004, I had to have some semblance of an off-screen model to access these dark corners of Microsoft Word. Thank you, Richard. Richard says it was worth it to all of us who still use it. But we needed some semblance of an off-screen model to access these dark corners of Microsoft Word, the menu bar and Real Player, and to begin to provide access to Skype. Although Skype became one of my nightmare test cases for the off-screen model in version 2. So late November, early December 2004, I had stumbled upon this technique of API hooking while I was looking for the answer to something else. And I realized, sort of independently rediscovered that I could use this for an off-screen model. And later found out that, like I said, this was what other screen readers did in the Windows 9X family of operating systems. So I started working with that. And like I mentioned, to do this API hooking, you had to inject some of your code into the application process. And this basically meant putting some of your code in a DLL file, a dynamically linked library, and instructing Windows to load that DLL into the application process and then run some of the code from that DLL inside the application. And I read a blog post the other day from a fairly famous developer on the Windows team at Microsoft named Raymond Chen. He has this blog called The Old New Thing, where he talks about obscure topics in development and Windows. And he did a post the other day about a technique that someone was trying to use for injecting code into a process. And he said, you can't do it that way. It's more complicated than that. And then he said the safer footnote way of injecting code into a process is to inject a DLL. And the footnote was basically to say, I said safer, not safe. So, and he was right. It's tricky to do this right. I've debugged multiple crashes over the years from getting it wrong. And the risky part of this is the crash very often brings down the application, not the screen reader. Richard, I know you've been listening here, chatting away. You and I worked on multiple such debugging sessions. But anyway, this process of this technique of injecting code. Yes, good old WinDBG, the Windows debugger. But this technique of injecting code into the application process gave me the solution for both problems that I mentioned earlier. Because the other problem, as you'll recall, was that accessing Internet Explorer in a cross-process way was unusably slow. So the solution to that was to inject all of the code that needed to interact with the Internet Explorer DOM into Internet Explorer. Now, in order to do this, though, I had to revisit what programming language that code was going to be written in. You'll recall from earlier, it was implied, if not outright stated. The first prototype of System Access was written all in Python. And there was no way I was going to inject a full-blown Python interpreter into multiple application processes. But there was also no way at that time that I was going to write sizable amounts of complicated code really any more than I had to in C++, which is what the other screen reader developers did and still do for their code that runs. Yes, yes, Richard, you're on exactly the right track there. This is where the Lua programming language came into the picture. And Lua was and is a dynamically typed high-level, what's often called a scripting language. High level meaning it had things like garbage collection for automatic memory management and a form of exceptions for error handling and other sort of convenience features above and beyond what you get with something like C++, all coming at a substantial efficiency cost, of course, but much more efficient and in particular, way smaller code size and memory usage than Python. And when I found Lua in late 2004, I fell in love with it and decided that this was what I was going to use for as much as possible of the code that had to run in process, basically being injected into application processes for system access for the screen reader. And so I translated the web browsing code. Again, it had originally been written in JavaScript for the Mozilla based FreedomBox 2.0 browser. I had translated it into Python for the doomed out of process attempt, and then translated it again to Lua. And this was the translation that has stuck for well over a decade now. Got that done in time to release System Access version 1.0. And Lua had available for it some off-the-shelf libraries, which I found useful. And one of those libraries was called LuaCom for accessing a subset of the component object model COM from Lua. And that helped me a lot in accessing the Internet Explorer DOM. But what I quickly found was that I needed to access other COM-based interfaces that weren't available through LuaCom. Basically, if anyone any programmers here are familiar with COM, if you know about the difference between IUnknown versus iDispatch, LuaCom only gave access to iDispatch or OLE automation-based COM interfaces, and I needed access to some IUnknown-based interfaces and to some other Win32 APIs. So I started developing my own set of Lua Windows API wrappers, which I called Lua Win. And at some point, I put a snapshot of Lua Win at a particular point in time up on one of the open source code hosting sites that existed at the time. But Lua Win has, for all practical purposes, been an internal to Ceratec code library that was developed and added to over several years. So for System Access 1.0, I got our Internet Explorer access code running in process, and basically everything from receiving the keystroke to doing all of the processing, and then building up the string or strings to be sent back to the speech synthesizer would run in the Internet Explorer process, and then it would send the speech synthesis commands back to the main system access process, and the speech synthesizer was running in that main process. And so that was a success. Well, I mean, yeah, technically it was a success in that it dealt with the efficiency problem more or less. I mean, my Lua based code probably wasn't as efficient as a pure C++ version would have been, but it was back to being on par with what we had in our Mozilla based browser. So System Access 1.0 was released right around New Year's 2005. And then we went back to and did some more work on FreedomBox, the browser and online service. Although in FreedomBox version 2, the browser was kind of the star of the show. The online service was still critical to what we were selling, providing a simple interface to accessing all of these services and content that we were providing access to. Although the old shopping mall interface based on screen scraping, Amazon, that fell by the wayside, because now with the FreedomBox browser, you could pretty much use Amazon directly. But we worked on some other service. We worked on some other additions to the service, such as being able to read RSS feeds and listen to podcasts. Put together a simple personal website. And then on the local software side, we added CD ripping and burning. This still being well before music streaming went mainstream, and iTunes and iPods not really being accessible at this point. So FreedomBox version 2.2 came out in summer of 2005, and then when we were finished with that, I got to work on System Access version 2.0. And at this point, I decided to really double down on injecting as much code as possible in process, because while the sort of bolted on solution that I had come up with at the end of the 1.0 cycle worked okay, it was kind of jury rigged and not it didn't fit smoothly into the design that I had at that time, where most of System Access was running out of process. So for version 2.0, I rewrote big chunks of code in Lua, and then the off screen. So the code that intercepted these graphics function calls and gathered information from Windows APIs to complete the model. That code was in C++, but then the code for maintaining the data structures of the off-screen model and doing the heuristics on top of that was all in Lua. And of course, suffered from that in terms of efficiency. I have my opinion about what programming language I would use if I were doing this today, but that programming language didn't exist back then. It's the Rust programming language, which is kind of the efficiency of C++, but the safety and robustness and some of a lot of the developer productivity of higher level languages. But regardless, that didn't exist back then. So I doubled down on Lua for System Access 2.0 and spent several months from summer of 2005 through the spring of 2006, rewriting code, adding features, making the off-screen model more robust. As I mentioned, yeah, Skype was one of my nightmare cases for just trying to make the off-screen model as smart as I could manage. Skype was doing some crazy stuff back then. For instance, the contact list didn't use a standard solid background color for the highlight. And I realize it has now been over an hour and I'm still in 2005. So just keep going. But Skype used this sort of gradient sort of thing for the highlight. And but they did it by drawing lots of small rectangles in this pattern. And so other screen readers at the time couldn't detect the highlight in the Skype contact list. Well, I was a cocky 20-something. I figured I could, I had a small taste of the power of building an off-screen model using API hooking. I figured I could do this. And so I came up with a heuristic for detecting the averaged background color and looking for the minority background color of all the pieces of text on the screen and taking that to be the highlight color. And it worked, basically. One application, though, that just defeated my best attempts to develop a smart off-screen model was iTunes. And iTunes had a fully custom user interface, at least in the main window. It didn't use standard controls for anything, at least not standard Windows controls. I'm sure at some level they were porting their Macintosh interface over to Windows, but as far as we were concerned, it wasn't standard, and it was using a feature of the Windows Graphics Device Interface (GDI) called DIB sections, where DIB stands for Device Independent Bitmap. And basically, I mean, any programmers in the audience can Google that to learn more, but it allowed the application to manipulate the memory backing that to basically manipulate the memory for that part of the screen directly. And so what it amounted to was that the application could sort of go behind my back and do things to the to that part of the display that I couldn't pick up by intercepting GDI function calls. And I still don't know how the other screen reader developers dealt with this. If they did, they might have had access to additional tools for picking up on those sorts of things, since they were running a driver in the kernel. But of course, they were our competitors, so we didn't exchange information. So here I was trying to do it my own way, doing like before and after comparisons of the contents of the memory. And I was able to make it work sort of, but not really. So like I said, iTunes just defeated me and would continue to be not very accessible to anyone for a few more years. But other than that, things were looking good for System Access 2.0. And towards the end of 2005 and into beginning of 2006, I fell into what you might call demo-driven development, because Mike convinced me that I should produce a series of audio demos / mini tutorials for System Access in various scenarios. Windows Control Panel, Internet Explorer, Outlook Express, Microsoft Outlook, Microsoft Word, command prompt. We did make the command prompt window accessible. And so I recorded all of these demos, and on several occasions while I was going through recording my demo, I would find that some aspect of the user interface wasn't as polished as we would want, and or some access to some particular feature might have just been outright missing or broken. And so I would go back and work on that and make it work the way we needed it to for the demo, and then go back and record again. So demo driven development. And then we released a public beta, I think, of System Access 2.0 in Groundhog Day 2006. And then public release later that spring. One of the things that we added later that year was remote access, and using the VNC open source remote desktop package, combining. So we combined VNC with our own protocol on top for or running alongside rather for carrying text to speech commands across the connection, and also our own system for establishing the connection, and having the client end would contact our central server and request a connection. The central server would contact the either the user's home computer or the computer of the other user that was being connected to. We had both versions of this by middle of 2006. And so users on our online service could connect to each other and help each other out. And then later that year, we turned the remote access feature into a pair of products, which again, we've never been great at product names, except perhaps for the original Freedom Box name. But we called these products Remote Incident Manager, or RIM, and Remote Access Manager, or RAM. And the difference between it was basically two licensing variations for the same product. RIM was for remote tech support and training, where someone would be supporting or training a set of users, and this would be done over the internet using a central server that we ran, whereas Remote Access Manager, or RAM, was for a person working at an IT or help desk type job in a corporate environment, and that was running on a server within the corporate network. And so we started selling that in end of 2006, beginning of 2007. Yes, Richard pointed out that RAM could also be used for an IT person gaining unattended access to computers, for instance, accessing servers, or just going around and doing stuff on desktop computers within the organization, maybe at night while people weren't working, for instance. So spring 2007, we worked on making our access to Microsoft Office more full featured, including access to Microsoft Excel and PowerPoint. We had previously focused mainly on Microsoft Word, but we built that out some more. And then summer of 2007, Mike came to me with his next great idea, which was System Access to Go. And this was basically a version of, like I mentioned, we had our software running on a USB flash drive. I'll briefly mention that in 2006, we worked with an industry standard that existed at the time called U3, which was basically a standard auto run mechanism for running applications off of a USB flash drive. And we got System Access into the U3 marketplace, and also came up with our own procedure for installing system access onto a U3 drive without going through the normal U3 installation procedure. But at any rate, we had system access running off of a USB flash drive. But in 2007, Mike had the idea that someone sitting at a public computer should be able to go to a website and download and run system access without straight from the website without having to go through an installation procedure first. And in particular, what occurred, Mike came to me and said, wouldn't it be cool if you could go to the website and using Flash or whatnot, it could just talk you through the process of downloading and starting the screen reader. And I went off and investigated what would be possible to do with Internet Explorer, and I stumbled upon a behavior of the Internet Explorer download procedure at that time, that a quirk of the way it worked, that the way it worked at a low level networking layer. And I realized that yes, we can actually know. So the way that Internet Explorer worked at that time when you wanted to download a file was you would activate the download link and it would pop up a dialog saying for a .exe file, it would pop up a dialog saying, do you want to run this or save it? And it would be Alt-R or Alt-S. So you would press Alt-R, then it would go off and download it. And then it would pop up again saying, do you want to run this, just to confirm it? And it would show you information about the file that it had just downloaded. And you would press Alt-R again, and then it would run. Obviously, this isn't the way it works with any modern browser now, but it is, the way it worked at the time. And it may be surprising to learn that even on publicly accessible computers, this process was wide open. You could do this. And I discovered that by paying close attention to the flow of packets over the network during the download process, we could detect when that first Alt-R or Alt-S dialog came up, and we could play that prompt. We could play a prompt telling the user press Alt-R to continue, and then by detecting when the download was done, we could play, insert another little delay and then play the second prompt, press Alt-R again to continue. So by using either Flash or the Windows Media Player ActiveX control at the time, we could play pre-generated text-to-speech prompts to guide the user through the whole process, and then actually running the package that you had just downloaded was a simple matter of extracting. And then once after the second Alt-R prompt, you'd have a full screen reader for logging in and taking it from there. Because we could just extract, do a little self-extracting archive, extract into a temporary directory, run it, and then once the program had been shut down, the self-extractor would wipe the temporary directory more or less, and at least after the next reboot, it would be gone without a trace. So that was System Access to Go, and I developed that in pretty short order in the summer of 2007, and we put it out for public beta for people to just play with free of charge, and it was a big hit. And the other thing that I started prototyping before the big national blindness conventions of the summer was Braille support. Starting with I think we initially prototyped support for a HumanWare Brailliant refreshable Braille device using the Baum Braille protocol. Baum was one of the major manufacturers of Braille displays, and there was no standardization at the time in how screen readers communicated with Braille displays. There is now finally a standard based on the USB HID, Human Interface Device standard USB device class. But back then, you would have every Braille device would come with its own USB driver for intercepting with whatever USB to serial port adapter the device was using internally. And then, so that was the low level transport layer. And then at the protocol layer, which was the bigger problem, every device had its own, or every device manufacturer had their own protocol for communicating with the screen reader over a serial port connection. And the USB and Bluetooth interfaces that were added later were based on those serial port protocols for the most part. So, no standardization. Every screen reader had to implement support for every Braille protocol. But we started with the Baum protocol and prototyped some quick and dirty Braille support, and took that with us to the summer conventions in 2007, and then began to build out Braille support more in coming years. Yeah. Yes, the Alva BC. Yeah, thank you, Richard. The one of the first Braille displays we supported was the Alva BC640, which also doubled as a USB flash drive. And so, of course, you could install system access on the flash drive portion of that. So, and so the kind of the next big thing that happened was we phased out the FreedomBox 2 Mozilla-based browser, and in fall 2007, we started developing our basically an alternate user interface over the Internet Explorer browser engine, and started using that for accessing the FreedomBox network and and just for providing a streamlined web browser interface for people that wanted that. The other thing that happened around that time was we had to drop the FreedomBox name because we got sued by the company Freedom Scientific, which was the owner of the JAWS screen reader and various other products. They sued us for trademark infringement because Freedom Scientific, FreedomBox, I guess. And we had to drop the FreedomBox name. So FreedomBox System Access became just System Access, and the FreedomBox network became in truly indicating what a different world it was back then, and that mobile meant something else, at least to us pre-iPhone, became the System Access Mobile Network, which was then shortened to SAMnet, later renamed Sero, which is a much better name, I think. But anyway, so that was happening, and then and we dropped the Mozilla-based browser. Well, I guess we offered the Internet Explorer-based browser interface, initially as a preview, and then a little bit later we dropped the Mozilla browser. Early 2008, we announced that System Access to Go was going to be free indefinitely through a foundation that we had set up called the Accessibility is a Right, or AIR Foundation. And also early in that year, we started making the Freedom Box Network audio content available on portable audio players, beginning with the Victor Reader Stream, which was and is a talking portable audio player for blind people. And you could hook it up to your PC through USB, and we could detect that USB device and then transfer audio content onto the SD card that was inserted in the player. And then some of the audio content that we offered was protected through a form of DRM. And so that was going on. And then I implemented a basic screen magnifier using either the Windows magnification. Oh, yeah. Thank you, Richard. I almost forgot another little side thing that was going on in 2008. There was a PDA called the Icon from a company called Levelstar. And there was another variant of that same platform that the American Printing House for the Blind put out called the Braille Plus. And it was a Linux-based PDA that had its own text-to-speech based user interface. It wasn't a screen reader for a graphical user interface. It was a screenless device with its own interface and its own applications written in Python. And we got in contact with the developer and developed our own add-on for that PDA to provide access to our network and our audio content, and you could even connect back to your home PC and listen, stream music from your media library. And so that was going on in 2008. Then, like I mentioned, I developed a basic screen magnifier as a feature that could be turned on in System Access using either the Windows Screen Magnification API or the or a hack on top that using Windows GDI and layering of Windows, depending on what version of Windows you were in, and if it was Vista, whether the Windows Arrow look and feel was enabled or not. Speaking of Vista, the thing I kind of glossed over from 2006 to the beginning of 2007, System Access was available on Windows Vista from the day that Vista was released to retail, January 30th, 2007, I think. And I'm going to back up a bit and talk about Vista, because I think this is one of the more interesting topics that I kind of glossed over. So we started hearing about Windows Longhorn back in, or at least I started hearing about it back in 2004, maybe early 2005, not long after I had gotten into the screen reader business. And what we were hearing at the time was that Windows Longhorn was going to be just this big change, a big do-over to the way that Windows worked. It was going to be all different based on the .NET programming language environment. Brand new user interface framework, new accessibility API, not backwards compatible with old screen readers, all this stuff. And it was a while. I was not one of the first to gain access to the betas. In fact, I didn't get my hands on a beta until summer of 2006. And when I finally did, it was like, okay, some things have changed, but it's still basically Windows. And one of the things I didn't understand at the time was that the Windows Longhorn project did have bigger ambitions that matched up with what we had been hearing on the outside. But then at some point, the project was more or less reset and started over for the most part, starting with Windows Server 2003 as a starting point, because a lot of the bigger a lot of the bigger projects that had been attempted kind of got out of control and didn't work. And I'm retelling things that have since become public knowledge. I'm not revealing anything that I learned during my time at Microsoft much later. But nevertheless, there were a couple of big things that happened that did happen in Windows Vista. One was user account control, or UAC, which was the new security feature that Apple famously lampooned in their cancel or allow ad with the I'm a Mac, I'm a PC ads. I'm a Mac. Mac is introducing himself, cancel or allow, etc. And so there was the user account control security feature. And then the other big thing that actually did happen in Vista, at least for PCs with capable graphics cards, was the Windows Aero look and feel, which was backed by a technology called the Desktop Window Manager, or DWM. And while Windows Aero was the pretty superficial change to the visual appearance, fancier borders around the windows and not a whole lot more, DWM was a fundamental change to the way that the desktop is rendered and put together in the final rendering to the screen. And for any programmers in the audience, it was basically the introduction of a compositor into Windows. And along with that came a new display driver model. And yes, this spelled trouble for the driver chaining manager, which all the other screen readers were using in Windows XP. And so what the other screen readers had to do was, instead of chaining their own drivers, they would have these sort of mirror drivers off to the side in the display pipeline. And the process of installing and uninstalling these mirror drivers was cleaner than chaining fake drivers to the real display driver. But what had to happen on an Aero or DWM capable machine was that when one of these screen readers started up and the mirror driver was activated, DWM had to be turned off. So one of these screen readers starting up would be an immediately visible change to any sighted person that was watching. And so this had me and Mike feeling pretty vindicated about our decision to not touch the kernel level display driver stack with a 10-foot pole, as it were, and to do our hooking at a different level. And we wrote an article discussing so we wrote an article comparing the two different approaches and more or less gloating about the way that we were doing it. And Richard points out that these mirror drivers also disabled the ability to play back some DVDs, but in Windows Media Player, because the mirror drivers interfered with the premium content protection system in Vista, but System Access didn't touch that. So so we were feeling pretty proud of that and let everybody know it. But anyway, another thing that was starting to take off around this time was the NVDA open source screen reader. And the NVDA project started in summer of 2006. And I have to say, I was kind of a jerk to Michael Curran, to Mick at the time. I wrote him an email when NVDA first came out that was kind of really discouraging. Yeah, telling him how basically how far they had to go and how hard it was going to be. And Mick, if you're listening, I'm sorry. I'm sorry. I approached you like that. But I mean, it's a long time ago. We've been on good terms for a long time, but yeah, and I underestimated them, to be honest. I underestimated those guys, and it took time, but NVDA did grow into one of the most capable screen readers for Windows, that has provided access to Windows for a lot of people. I realize it's been almost 2 hours, so I'm not going to keep going year by year. I'm just going to hit some of the high points here. So in 2008, we rewrote large parts of system access, more of system access, and the software for accessing the online network in Lua, so that we could offer a smaller download as part of System Access to Go. And then yeah, we were, I think, the first commercial screen reader to support access to 64-bit versions of Windows. Yes, I was just getting to that, Richard. 64-bit. And because we weren't doing anything at the kernel level with mirror drivers and whatnot, that was a pretty straightforward process once I had a 64-bit capable computer, which I got in the summer of 2008. Yeah, nobody did it before me, but then because of the earlier decisions that we had made, it really wasn't that hard. So that was 2008. Windows 7 was not a huge change, although Windows 7 did mark the introduction of the UI automation accessibility API as a core component of the operating system for the first time. It was there in Windows Vista, but I don't think anything in the actual operating system was actually using it. So I think we all just kind of ignored it during the Vista timeframe. But in Windows 7, the start menu search box, among other things, was dependent on UI automation. And if I get to the Windows 10 timeframe tonight, then UI automation and will make a much bigger appearance, starting with Windows 10. But let's see. The big thing that happened in 2009, though, that shook the whole industry was the iPhone. And I forgot to mention that iTunes for Windows became really accessible for the first time in September 2008. The way that they did it was not very elegant. Presumably, the Apple iTunes team got help or at least advice from one of the screen reader manufacturers. But if they did, I have to say they got incompetent advice, or at least the way that they handled it was incompetent. It was still a struggle for me, at least, to make iTunes usable with a screen reader, even though Apple had supposedly implemented their end of accessibility And this is touching on the problem that I'm hoping to solve with my Access Kit project, which I still hope to demo at some point tonight if anyone's still here. Yeah, iTunes for Windows had become accessible in 2008. And as part of that, they had with the 4th generation iPod Nano, they introduced a way of having the computer pre-generate text-to-speech audio clips and send those to the iPod, so that you could use an iPod with text-to-speech, but not with the speech synthesis running on the iPod. But since the launch of the iPhone in 2007, we had all just assumed that the iPhone was never going to be accessible to us because it was a touchscreen device and it was a closed platform. So there was no way that a third-party screen reader was going to run on it. Some of the earlier generation smartphones had been running third-party screen readers. I'll just mention this briefly. The Symbian platform had a product called Tox. The Windows Mobile platform had MobileSpeak Pocket and Pocket HAL. But of course, those smartphones, I mean, they had their niche audience, but they never really hit it big. The iPhone, to use the cliche, kicked off a revolution. You had there's an app for that ads starting around 2009. And in summer of 2009, to all of our astonishment, Apple announced that the third model of the iPhone 3GS, included a built-in screen reader, VoiceOver. A built-in free, well, I mean, as part of the phone. The iPhone itself was not cheap, but if you could get an iPhone, and if you were on the right carrier for that at the time, then you would get a screen reader built into that. And like I said, that just shook the access technology industry and really changed the rules of the game and gave the blind community access to a whole new world that we had never had access to before. And because the iPhone had so many useful sensors and connectivity options and things built in to the hardware, tasks that used to require special purpose hardware devices, such as GPS navigation, currency identification, lots of other tasks involving computer vision using the camera, document reading, eventually. Barcodes could be done on the iPhone. And so back at Seratech, we started dipping our toes into the water with the iBlink radio app, which offered access to a small selection of internet radio stations and other audio content from our network on the iPhone. In later years, we offered access to the full range of content and services on the network on iPhone and later on Android as well. I think it took a while for it to sink in with us that the combination of the iPhone and the NVDA screen reader on Windows meant that the SamNet, which became Sero, was later made available on Amazon Fire OS as well as Android. But like I was saying, it took a while for us to realize that that the combination of the NVDA screen reader on Windows with the iPhone meant that the niche that we were trying to fill with FreedomBox and FreedomBox before it and System Access and SamNet at this point was basically trying to make things affordable and easy to use for people doing basic tasks on a home computer, that niche wasn't going to be as profitable as it had been. And but that change, of course, was slow to come. So just trying to hit some more of the highlights. I was developing other products as well as the system access screen reader and the online network. In 2010, 2011, we beefed up our document scanning product and substantially updated the functionality and rebranded that product as DocuScan Plus, which also became our first application for the Mac platform. On Windows. It was kind of built into the System Access and SAMnet software suite, and if you ran it by itself, it would still use System Access use the System Access screen reader in a restricted mode for text to speech output. On the Mac, DocuScan Plus ended up being just an application that you would run with the built-in voiceover screen reader on the Mac. So we had that going on. Feature development on System Access itself slowed down. But one of the big things I remember doing in summer 2010 was writing drivers for several more Braille displays. Remember, no standardization of Braille display interfaces. So we wrote drivers on an on demand as needed basis. Let's see, I'm trying to pick up the pace here. I'm probably not going to cover absolutely everything, but Windows 8, of course, started. Microsoft first announced that in fall 2011 and released it about a year later. And the changes in Windows 8 were, from our perspective, fairly superficial. I mean, for a visual user, it was a big jarring change to this full screen interface, replacing the start menu and so forth. For us, yes, things had changed, and it's common for Windows screen readers to have to do special case hacks to work with various parts of the operating system, and especially for us to try to make them work in a smooth and intuitive, easy to use way. And I had to do some new hacks for Windows 8, but there was nothing really earth shaking going on at a fundamental level there. UI automation was being used in a big way in the new user interface frameworks that were introduced as part of Windows 8. I say frameworks because there was more than one. As I would later find out from the inside, things were always chaotic in the Windows organization at Microsoft, that it was never as coherent as, say, the Apple user interface. Windows 8 also, of course, introduced the Windows Store, which was Microsoft's answer to the Apple and Android app stores. Never really took off in a big way. So we were there on Windows 8. We didn't have to make any huge changes to System Access. Windows 10 was a bigger deal, and I'm just going to jump straight there. Windows 10 was from a visual perspective, Windows 10 was kind of a retreat from some of the bigger, more jarring changes of Windows 8. There was a start menu again. it wasn't a return to the Windows 7 start menu. It was a new start menu. But the really big thing that happened in Windows 10 that was pretty scary, I think, and I think I can safely say this for all of us screen reader developers, was Microsoft Edge. This was the new replacement for Internet Explorer. And the thing that made it scary was that Microsoft Edge finally and definitively, and with very little warning, especially for me, since I didn't get the same advance notice as the other screen reader developers due to some basically the new the Windows accessibility team at that time didn't know about me and Saratech, so I didn't get invited to the meetings that the other screen reader developers attended, but they kicked us out of process. We could no longer inject our code into the browser process and have access to the document object model in the way that we had before. Now, no doubt that was a very good thing from a security point of view, but it meant that we screen reader developers had to basically go back to the drawing board and redo the way that we provided access to the browser. And I wrote a blog post about this in 2016, but there were a couple of big problems. A couple of big problems in my view, and several smaller ones with the way that Edge tried to give us access to the web content. And basically their answer was, you're going to use UI automation and that's it. And the two big problems were, one, UI automation didn't give us access to all of the raw information that we were able to get out of the IE DOM before. For instance, if you had an unlabeled image on a web page, before we could access any of the raw HTML associated with that image, we could access the source URL, other bits of information, and combine any of that information into a heuristic to try to do something useful with that image. In Edge, we had nothing. If the image didn't have proper alt text on it, we couldn't do anything else with it. And there were the same applied to any other attempts really to work around inaccessibility on web pages. So that was problem number one. Problem number two, to put it simply, speed. We back to the old problem I mentioned, an hour and a half ago, with just the inefficiency of accessing things in a cross-process way. And luckily for us, before the switch over to the Chromium browsing engine, Edge didn't really amount to much. So it didn't end up being as scary as it could have been. But boy, I was stressing about that around the release of Windows 10 in 2015. Because, I mean, I didn't know. I thought it, well, what I was really thinking at the time was everyone else is going to be ready and I'm not. And of course, that turned out not to be the case. So that was kind of a relief. But so like I said, I wrote a blog post about it, and I was also in fairly frequent contact with Microsoft. And in late 2016, I did get invited to a meeting of Access Technology developers in Redmond. Well, a series of meetings over a few days. And the major topic of discussion in those meetings, I mean, there were other topics, but the big one was Edge, and the NVDA guys, and full thanks to those guys who had been very diligent about this. had compiled a list of issues with Edge, not just the two big ones that I pointed out, although I made sure to, well, I mean, all of us were concerned about the speed issue. And I continued to make my case for continued raw HTML level access, but the NVDA guys drilled into lots of smaller, lots of, more fine-grained, but also crucially important things as well. Those meetings were my first introduction to the then current accessibility team, Windows accessibility team at Microsoft. 2017, the other big thing that happened for Saratech in 2016 was we finally renamed SAMnet to Saro, and we basically unified the desktop and mobile apps and had a more or less unified cross-platform app. And so early 2017, it was clear to Mike that Saratech was kind of in financial trouble, and we needed to either, well, we needed to try some things to bring in more money, or we needed to start looking at winding down. And on the trying new product packaging front, we introduced new inexpensive subscriptions to Saro for specific platforms, so you could pay $6 a month and have Saro for iOS or Android or Windows. But then around April 2017, Mike found a job opening on the Windows accessibility team at Microsoft, and he called me up and he basically said, "Matt, you need to take this." And so I applied, and I went and interviewed, and much to my surprise and delight, I got the job. So I moved to Redmond, Washington in June of 2017 and started working on the Windows accessibility team at Microsoft. And I won't talk a lot about what I did and what we did there, but I'm happy to say that I was able to contribute to feature development and Narrator during what I consider to be its golden run from 2017 to 2019, with the last big set of new Narrator features being released in spring 2020. One of the features that I contributed to, that I led the development on, was the overhauled keyboard layout for Narrator, which basically brought the Narrator keyboard commands in line with what people, more or less with what people expected from JAWS or NVDA or System Access. And I also worked on the Narrator support for the Chromium and Firefox browser engines. At this point, I'm going to step back and talk a little bit more about accessibility APIs. So Microsoft, like I said, the original accessibility API for Windows was Microsoft Active Accessibility, MSAA. MSAA hang on, I'm getting a text message. Oh, a Q&A. Oh, okay. So the open Q&A is, where is Saro today and Numa Solutions? So the Saro online service is still chugging along. It's still pretty much in maintenance mode at this point, although it is owned by Numa Solutions, which is the company that Mike Calvo and I co-own at this point, which is basically picked up what's left of Ceratec. And we are getting ready to start doing some more work again on Cero in the new year. So I hope that answers that. Let me just answer. Once I can reread this chat message. Remote applications similar to JAWS Tandem or NVDA Remote. Stay tuned. Numa Solutions is going to be doing a revamp of our remote incident manager product that I touched on earlier. So that's coming in the new year. So hope that answers that. Now, as I was saying about accessibility APIs, so Microsoft Active Accessibility, or MSAA, was the original accessibility API for Windows. And it was, as you may recall from way back, so limited that I couldn't even use it to access Notepad. IBM decided that they wanted, IBM in 2006 decided that they wanted to solve that problem so they could make their Office suite accessible. And they extended MSAA, and following a naming convention that was fairly common for interfaces using COM, the component object model, they called their new API iAccessible 2, because the main COM interface of MSAA was called iAccessible. So you had iAccessible 2, or IA2 for short, and Mozilla really latched on to that and used it as the accessibility API for Firefox. And then when Chromium started implementing accessibility in earnest in around 2011, they basically imitated Firefox's implementation of iAccessible 2. Meanwhile, at the same time, as I've mentioned a few times now, Microsoft's answer, Microsoft's official successor to MSAA, starting in Windows Vista. Thank you, Richard. But so starting with Windows Vista, introduced for real, I would say, in Windows 2000, Windows 7, and then really picking up steam in Windows 8 and Windows 10 was UI automation. And the UI automation API was technically superior to both MSAA and iAccessible 2 in some ways, but the third-party browser makers didn't really embrace it, and mostly still haven't. Although Chromium is beginning to, but even that effort is mostly driven by the Microsoft Edge team, as I understand it. So the third-party browser engines continue to depend on iAccessible 2, but Narrator, until starting in 2018, had no access to iAccessible 2. So I was part of the effort within the Windows accessibility team to make iAccessible 2 supported within Narrator. And I did a lot. I mean, I didn't do any of the like key architecture or design work on that, but I came in and did a lot of the debugging on that, and I'm proud that we were able to make that work so people could use Chrome, not only the Chrome browser, but also applications that use the Chromium engine, including some key applications within Microsoft, such as Microsoft Teams. And then after that, I think that the single project that I participated in at Microsoft that I'm the most proud of was an answer to the inefficiency problem with using UI automation in an out of process way. And the solution to this that one of my brilliant colleagues at Microsoft came up with, and it just did an excellent job of leading to fruition, was an API that has now finally been introduced in Windows 11 called Remote Operations. And I won't go super deep into this because, well, we're running out of time. I mean, I'm already over time according to the original schedule, but any programmers in the audience or listening to the recording can research this on your own. But the short version is that Remote Operations introduces a purpose-built opcode, bytecode interpreter into UI automation, so that a screen reader or other access technology or UI automation client, such as UI automation, as the name sort of implies, is used not only for accessibility but for test automation and things like that. But a UI automation client program, such as a screen reader, can construct a bytecode program that requests a series of UI automation operations all at once, tied together with arbitrary program logic. So it can do things like grab this text range from a document and go in a loop through all of the words on the range, gather up the text and the bounding rectangles of all of the words, and then ship it all back to the client at once. And so a screen reader like Narrator that needs to do something like read through, when doing continuous reading, it has to go, it needs to keep track of the boundaries between words and move the highlight rectangle from word to word to word. Whereas before, it would take many cross-process calls per word, meaning lots of overhead to gather to do that procedure. Now it can just send this little program really across the pipe from the narrator process to the application process, have UI automation running inside the application, do the whole operation in one shot, and then send the result back all at once. And it's I think that Windows 11 users, if they haven't noticed this already, Windows 11 users using Narrator can look forward to substantial performance improvements because of this feature. And eventually, to the extent that other third-party screen readers use UI automation, they will be able to take advantage of this as well, because this is all a public API. And like I said, one of my colleagues did the original design and led the implementation of this, but I'm happy that I was able to be one of the developers doing a lot of the implementation work on this. And and another thing that I contributed to that has also come to fruition in Windows 11 is extensibility within UI automation, which, among other things, means that a browser implementing UI automation can have a way of returning more of that raw information from the HTML that I was advocating for back at those meetings in Redmond. So when I did eventually leave Microsoft, I was able to do so with a real feeling of mission accomplished, in that I was able to contribute to solving, or at least getting on a path to solving, both of those problems that I had raised with the pre-Chromium version of Edge back before I joined. So yeah, that brings us to 2020, when I left Microsoft, and what's going on now. So Jane asked about Numa Solutions. That's the company that Mike and I co-own, that I left Microsoft to basically get off the ground. And what we've been working on over the past year is a couple of different products. And the first thing that I started working on after I left Microsoft is a program called Scribe for Meetings, which makes the PowerPoint slides, the screen shared slides in an online meeting, accessible to blind people. Now, Saratech had already more than 10 years ago taken a crack at solving this problem. But the way we had done it back then was by implementing an entirely new online meeting service called Accessible Event, which required the meeting presenter to run a program on their PC. And yes, even as we were developing Accessible Event, the post PC era was starting to happen. But we had developed Accessible Event as a PC bound product, basically. I mean, we did do a Mac port as well, a partial port for the Mac, but so it was an entirely separate online meeting service that required the meeting presenter to run a program on their PC. We've learned our lesson from that, and Scribe for Meetings is truly not trying to reinvent the meeting platform, but is designed to run alongside Zoom or Microsoft Teams and focus entirely on the accessibility gap, and doing so without requiring the meeting presenter or presenters to run extra components during the meeting. And then the other thing I've been working on is Scribe for Documents, which makes online, which converts documents, and particularly inaccessible PDF documents, into more accessible formats, and tries to fix the accessibility within. I mean, it can convert a PDF to alternate formats, such as a web page or a Microsoft Word document, or Braille file, or MP3 using text to speech, and can also output a PDF document with tagging, so it's accessible. So that's what I've been doing lately with Numa Solutions, which is the company that Mike and I are running now. But the other thing I've been working on lately that I'm now about to demo is a product called, well, an open source project rather, called Access Kit. Let me just take a quick look to see. I was just taking a quick look to see who's still here. So Access Kit is an open source project that aims to provide reusable accessibility infrastructure for GUI toolkit developers, or developers of applications that are based heavily on custom UI controls. And I mentioned accessibility APIs. The situation on Windows is pretty complicated. I mean, you can my advice to anyone starting from scratch on Windows now is UI automation, full stop, end of story. But implementing UI automation all by itself is not a straightforward task. You need to be conversant not only with the UI automation API itself, but with the COM object model. And there are pitfalls there around reentrancy and things like that. Any programmers that have worked with Win32 and COM know what I mean, I'm sure. And then other platforms have their own accessibility APIs. Mac has NS accessibility for as part of the Cocoa API. iOS has something similar as part of its UI kit, also known as Cocoa Touch API. Android has its own accessibility API. Linux, desktop Linux, or to be for the pedants, other Unix platforms based on the same technologies have the Assistive Technology Service Provider Interface, or ATSPI. Thank you, Sun. And I mean, thank you, Sun, sincerely for putting in the effort, and sarcastically for the name. And then of course on the web for UIs that are drawn using something like Canvas or WebGL, possibly using code compiled to WebAssembly, you have to create dummy HTML elements in parallel with that canvas in order to make it accessible. So anyone who is developing their own UI from scratch, who is used OpenGL or Vulkan or Direct3D, or quite likely a cross-platform wrapper over all three, to draw your own controls and handle your own keyboard and mouse input and whatnot. I mean, a developer doing that kind of thing has a fairly easy time, relatively easy time making their user interface usable visually. But then for accessibility, it's just this whole deep area that most developers just don't have the resources and time to get into. So what I am aiming to do with AccessKit is to provide a cross-platform abstraction over all of these accessibility APIs that developers can reuse in their applications and toolkits. And I owe a lot to the Chromium accessibility abstraction for giving me some ideas about how to go about doing this. And I've also been adapting some of the code from Chromium's accessibility implementation, and a lot of the the core data structures and list of control types and such come fairly directly from Chromium, although my design is diverging somewhat, and that's fine. But I'm implementing AccessKit in the Rust programming language, and I've chosen Rust because, like I said earlier, Rust is basically a combination of the efficiency of C++, with the safety, robustness, and a lot of the developer productivity of higher level programming languages. So happy to report that I got funding from late September through the end of this year to work on Access Kit from a team within Google. And now I'm going to show what I've got working. So just give me a minute to set up this demo. So far I've only been working on the Windows implementation of Access Kit using UI automation. And that implementation isn't complete yet. The biggest gap, and I'm aware that this is the same problem that I hit with Microsoft Active Accessibility within the first few days of prototyping a screen reader, but the biggest gap is missing support for text editing. Hang on, I need to focus on getting this demo running. So let me just get screen sharing going here. So the biggest gap is missing support for text editing. Oh, come on. I'm trying to get screen sharing going.
Meeting pane widget gal.
Okay, so I'm sharing my screen and I should be sharing my audio as well. I'm running the narrator screen reader with scan mode turned on. And what I've got up on the screen right now is the widget gallery for a GUI toolkit written in the Rust programming language called Druid. And Druid is the GUI toolkit that this team at Google that has been funding me is working on. And the reason I'm running narrator with scan mode is that Druid doesn't yet support tabbing for keyboard focus. So I'm going to use scan mode now to move through the screen, through the contents of the window. And this is my fork of Druid on GitHub, which has my Access Kit integration in progress. So all of this code is publicly available for anyone who wants to go check it out, play with it themselves. So I'm going to start down arrowing through this window. And with narrator scan mode, for those who aren't familiar with it, it basically means that I can move through the window like you would move through a web page with any of the major Windows screen readers. So I'm going to down arrow.
Title bar.
Here's
System.
generic window
Menu
title
item.
bar stuff.
Collapsed. Minimize. Restore. Close. Button.
I've got the window maximized.
Test.
And here is our first control, our first user interface element from Access Kit. Any sighted users in the audience will notice the blue highlight rectangle that is from narrator. And that narrator is drawing that rectangle using information that Access Kit is giving to it. And this widget gallery is laid out as a grid where the widget, a grid of various types of widgets where the widget is above the label. So it's the wrong order for reading through with a screen reader. And I'm going to figure out some way of fixing the accessibility order without changing the visual layout. But this is what I've got. So we've got the label test, and then going down
Label.
is the type of widget. Once I've got the order fixed, I will also be able to change these widget type, these labels that indicate widget types into headings.
Click me. Button.
So here's a button, and if I press spacebar in scan mode, narrator will do the default action on this button, which is the programmatic equivalent of simulating a mouse click. And if I down arrow,
Clicked 1 times.
later on, I will change that into a live region so that modified text will speak automatically.
Button.
And that is not an indication of a button, but again, is the label indicating the type of widget.
Check me. Checkbox unchecked.
If I press space,
Checked.
and in this case, you can hear that that the state change was that Access Kit fired an event for the state change, and I'm gonna do a I'm gonna start jumping around here a little bit. This being scan mode, which is narrator's equivalent of the browse mode or virtual cursor and other screen readers. We've got quick navigation keys. For instance, R will jump us to radio buttons.
Radio Gaga. Radio button. Selected.
I think whoever wrote this widget gallery must have been a fan of the Queen song Radio Gaga, because if I down arrow,
Radio Gugu. Radio button. Non-selected.
and if I hit space,
Selected.
and if I down arrow a little bit more here,
Radio slider. 50%.
and the narrator, so again, this Druid doesn't have keyboard focus yet, so I have to use narrator commands to manipulate the slider. If I press enter,
61. 72.
that increments the slider. Shift enter,
61. 50.
decrements it. Let me jump to the edit box.
Edit. Edit me. Press space to edit.
And like I said, Access Kit doesn't have full support for text editing yet. But this is the one widget within Druid where keyboard focus does actually work. If I press space
Focus on. Edit. Scan off.
and narrator scan mode shut off. If I now start editing, if I move through the field, Access Kit doesn't expose all of the necessary information through the UI automation text pattern to provide detailed feedback in here yet. So it's basically the same problem as, for instance, the chat edit control in the Zoom Windows app. So I'm in good company here. And this is temporary, of course. In fact, my next development cycle with Access Kit will focus on filling this gap. But if I type some new stuff
F.
in this control and then do insert tab to reread the control,
Edit. Some new stuff.
Access Kit is reflecting the contents of the control and you can read it back. So we do have that. And
Command prompt.
that is a quick
Pick meeting.
demo
Meeting control.
of what I've got going on with Access Kit so far. And like I said, this is all the code for this is all available on GitHub. I realize we're almost at 3 hours. Let me just see what has been going on. Anything, if anything, in chat. Okay, so I didn't miss anything in terms of chat messages. So to wrap up here, just looking forward a little bit at the future of screen readers. So Mike and I have had vigorous debates on the future of third-party Windows screen readers in particular. And Mike's position, which I can certainly understand, is that third-party screen readers have to go away because for the security and just general robustness of the operating system. I admit, I personally hope that they don't, because I think there will always be a place for blind programmers working on the screen reader and being free to decide how how we access what we need to access. I don't want us to just accept what gets handed down to us by the platform developers. So Mike thinks it's inevitable that we'll need to, and that and Richard, yes, thank you for pointing out that many third-party applications still don't work well with narrator, because the reality is that a lot of third-party applications are still using legacy code that requires a lot of what we call the hooks and hacks that third-party Windows screen readers have traditionally had to do. And while those hooks and hacks, like the off-screen model and the use of various esoteric features of Win32, while these don't work for new applications developed using modern programming frameworks and techniques, there are a lot of legacy applications out there where those hooks and hacks are still all we have. And beyond that, even, I think that even if third-party Windows screen readers are reduced to being just alternate skins on top of what's available through UI automation, I think there's still room for third-party screen readers to bring their own heuristics and their own ways of accessing what's available through the raw UI automation API. And as of this time, as far as I'm aware, narrator doesn't have the sort of scripting or third-party add-on features that JAWS and NVDA have. I obviously can't make any comment on the internal development status of any such effort, but even if it comes, even if scripting comes to narrator, there's no guarantee that that's going to give us the full flexibility that we need to take an application, possibly an application that's critical to one's job, and fill in the gaps in whatever level of accessibility that application might have provided. And so I hope that even if Windows is the only platform that supports third-party screen readers, I hope it still does for a long time to come. Now, there's another thing that's starting to happen with screen readers that some have said is going to be and has to be the future of the screen reader, and that is using machine learning to look at the actual pixels on the screen and provide and make sense of what's on the screen, having access to nothing more than the actual pixels, using optical character recognition to decipher the text, and using machine learning to figure out the types of controls and what has the focus and what's selected and all of those things. And Apple is taking the lead on this with the screen recognition feature of iOS. And that's certainly an exciting development. And I hope that other platform and screen reader developers follow suit. At Numa Solutions, we're certainly going to be looking into that and seeing what we can do in that area. Nothing concrete yet, but I don't think that I don't think that we should expect that to be the only way that we access that we access applications. I mean, it's not foolproof. I mean, and even as machine learning continues to develop, it's not going to be perfect. And fundamentally, the content and semantics underlying what's on the screen is there inside the application somewhere. I mean, it has to be there in the application in order for the application to render the user interface on the screen. And so I think fundamentally the right way to access to make that information accessible is to expose the underlying information that's already there in the application. Now, pragmatically, we'll take advantage of whatever techniques we have available to us to make an application accessible. Just as we do, just as we at Numa Solutions are already doing with making documents and online meetings accessible using any technique available to us. But I don't think that we should give up on making on continuing to push for proper access, programmatic access to applications through accessibility APIs. And that's why I'm excited about AccessKit being able to make that process easier for more application and toolkit developers. So that brings us up to that's what I wanted to talk about. And it's interesting point, Richard. Apple accessibility going backward because there's no competition. Let me see if there is a way that I can give Richard voice. If I can, hang on. I want to see if I can give Richard access to speak, because Richard, you've been chatting, you've been text chatting at me through this whole thing. And now that this thing is almost over. Oh, thank you, Richard. Oh, shoot. I think I forgot to actually record this thing through Zoom. So I hope that I hope it's been being recorded through YouTube. No. There you go. Okay, I just allowed Richard to talk. Richard, you should be able to unmute yourself.
Okay,
Hi, Richard.
I probably ended up slowing you down by doing all this chatting.
Oh, that's fine. Yeah, a lot of good points throughout the whole thing. So if there was anything else you wanted to say, then go for it.
No,
otherwise I think we're pretty much done.
Yeah, you've covered it extremely well, and what a history you've had over these this actually more than 20 years, but this last really since it's right at 20 years now.
Yeah, FreedomBox 1.0 came out on February 16th, 2002. So
yeah,
we are coming up on 20 of actually being released
in the commercial business of this. Yeah, absolutely.
Yeah, and it was I mean, pretty much starting with New Year's Day. So yeah, Freedom Box, right around New Year's 2002 was when I really started in earnest to take over the development of Freedom Box version 1 and bring it to completion. So
I didn't see Freedom Box for the first time until around April or May of 2004, but
the Linux version,
that was the second. That was
version
Freedom Box 2, I think. And again, I first saw it on Linux. I was actually running a Fedora box at that time, and we had a little bit of fun getting USound to run on that. But it was
Fedora was and ever is very bleeding edge.
Yeah, it is. And so anyway, what blew me away more than anything, still blows me away, is the intuitive, the intuitive web elements, not having to go between scan mode and browse mode, or browse mode and forms mode and all that stuff.
That kind of, I never really had the latitude to try to duplicate that in Narrator while I was at Microsoft. I would have run up against major technical challenges with that at any rate, given the architecture of Narrator.
The other thing that I think there is a lack of knowledge about in the community out there. Somebody a while ago was talking about remote access, and that when are we going to do a remote access product? System access, you mentioned it kind of in passing, the VNC stuff that you did to get the remote access working, not only in system access, but in RIM and RAM, basically voiced by system access. You turn those screen readers off, you run Narrator, it didn't work in Narrator, but it does work in JAWS, NVDA. And I'm helping people with problems using those tools because they are robust. They especially RIM. You come disconnected, it reconnects automatically. You can reboot their machine. It connects upon
new RIM in the new year is going to be a lot more robust, and it's finally going to carry all audio over the remote session.
That would be great, because then you could actually even use Narrator if you needed to. So
absolutely.
But this is, I'm telling you, people don't know that that the person who said that sounded like they didn't even know System Access or that Numa Solutions already has a remote. Ceratec had one. Numa Solutions has one.
I mean,
can it be better? Of course it can. But it's there. It's already there. Use it. I'm just. I guess I'm an evangelist when it comes to this stuff. Remote.
Yes, you always have been, and we've always appreciated that.
Yeah. But that was the only thing that I thought maybe needed more emphasis, was the remote stuff, because it changed everything. I mean, and NVDA remote came later as a crowdsourced thing that Tyler and Chris did, and great work there. And JAWS Tandem, but remote. Listen, SA remote stuff was first,
I guess JAWS and WindowEyes were first in a way with their solution for using RDP.
Well, RDP, but that was only for machines that could do it. You had to have extra licensing. But the Tandem, from user to user now, the way Ceratec did it right. I mean, they did.
Well, thank you.
You guys did it right, and it was great it was a great support tool when I worked there, and it's a great support tool now. That I'm just out in the wild, helping people with all different kinds of things. So it's probably the most important tool I have is remote services.
That's good to know, and hopefully you will like what we've got coming in the new year.
I'm looking forward to seeing what happens next.
Yep. Well, it's been nearly 3 hours, and I pretty much covered what I wanted to cover. So I'm hoping that this that even though I forgot to record it on Zoom, that the YouTube stream will be recorded and will remain available.
Yeah, be sure to link to that so people can get to it. You may want to send that to, I'll help you.
I'll tweet it.
places to send it. You tweet it and we'll get it up on the Ceratech forums and all that stuff. So
Yeah, I didn't know what my audience was going to be like tonight, and I wanted to get into some deeper stuff that programmers would appreciate. So
yeah, you got above my head pretty quick there. I'm still I'm an under the hood guy, but code ain't my deal. I wish it were.
all right, well, I think I'm gonna call it a night then.
All right. Enjoyed it.
Thanks.
All of it.
Thanks for participating. Thanks for prompting me in a lot of stuff.
Yeah, it's great. Fun.
Yeah, it was fun. All right. Good night, everyone.